Hello, this is Mr. Buffington. This is our lesson about linear inequalities. We're going to graph them and solve what they are. Remember, with an inequality, it's written like this: x is less than 2. That means x can be anything less than 2. It can be really, really close to being 2, but it can never be 2. And any number is less than 2. So 1, x is equal to 1. X can be equal to any negative number. X could be equal to 1.99. X can be equal to anything that is less than 2. It works the same way for linear inequalities. What this is saying is that the y values are all less than this line. All right? So let's see what that looks like when we actually graph them. Here is the equation of a line. Y is equal to negative 1/3 x plus 1. All right? That's the equation of the line. When I change that to a less than symbol, notice a couple things change. First off, my solutions include everything where my y value is less than that line. So in other words, everything below the line. Remember, our y values go up and down, so if y is less than, it's below the line. Also, we changed to a dotted line. The reason that we did that was because we have the less than symbol. If it was less than or equal to this line, it would be a solid line for that line. Because y does not include the solutions of this actual line, we use a dotted line to represent that. All right, let's go ahead and graph an inequality here. We have the point where I think of it as a linear equation at first of y equals 3/4x minus 4. That's the way I think of it. I graph the line first, and then I worry about everything else. So first thing I'm going to do is I'm going to put the point at -4, because this equation tells me -4 is my y-intercept. I also know my slope is 3/4, or a rise of 3 over a run of 4. So I'm going to use that to graph a second point. A rise of positive 3 means I go up 3, 1, 2, 3, and a run of 4 means I move to the right 4, 1, 2, 3, 4, right here. Now I'm going to draw a line through those 2 points. Now I've graphed the line, y equals 3/4x minus 4. Now the question is, am I going to shade above the line or below the line when I'm actually solving? Because this is an inequality, so I know I need to shade one side of the line. My solutions include one side or the other side. So to shade one side or the other side, I can do this in 2 ways. One, I can look at this and say my y values are greater than or equal to this line. Y values go up and down, remember, so I would shade above. The other way of thinking about this is to actually pick a test point. Easiest test point is 0, 0. So if we pick a test point, what we can do is substitute the value 0 in for x and 0 in for y, because that's the point 0, 0. So it'll look like this: y equals 0, x equals 0. And we solve. 3/4 times 0 is 0, minus 4 is -4. So we ask ourselves, is 0 greater than -4, greater than or equal to -4? Yes, it is. Because the test point is true, we will shade on that side of the line. All right? Both methods work. I think just looking at the symbol and deciding whether it's above or below is easier, but you can take a test point and that's fine too. All right, so that's how we would graph when we're given a linear inequality. The other question is when we're given the graph and we're asked to write the inequality. So first of all, with that, I'm going to write the equation of the line. To do that, I'm going to use my slope-intercept form of a line, which is y is equal to the slope times x plus my y-intercept, b. My y-intercept in this case, where it crosses the y-axis, is right there at 0, 0. So I have that point 0, 0. So that means b is equal to 0. My y-intercept is equal to 0. My slope, or m, is the rise, how much we move up and down, over the run, how much we move side to side. So I'm going to see how much did I move up and down from this point to this point. I went up 1, 2, 3. So that meant my rise is 3. I moved to my right 3. So my run is 3. Rise over run. 3 over 3, or in other words, my slope is equal to 1. Now I'm going to substitute that into my equation. 1 times x plus 0. 1 times x is x, and x plus 0 is x. So my equation of this line, this actual line here, is that y is equal to x. That makes sense with the 2 points that we have, 0, 0, 3, 3. If we continued on, 4, 4, 5, 5, 6, 6, negative 1, negative 1, negative 3, negative 3. All right, so our y value is always equal to our x value. That's the equation of this line. Now what I'm going to do is I'm going to translate that into the inequality. I have a dotted line, so I know I'm going to be using the less than or greater than symbol. Not going to be using the equal to symbol. So y is either less than or greater than x. And the way I look at it is I shaded everything above, therefore my y values are greater than. So I'm going to use the greater than symbol. We could also pick a test point. I picked, here's a good point right here. 1, 0. We pick this test point here, and if it's part of the solution, we should be shading below the line. If it's not part of the solution, we'll be shading above the line. So we can test that. When x is equal to 1 and y is equal to 0 is, we'll substitute that in over here, y is greater than x. Our y value is 0, our x value is 1, and that is a false statement. 0 is not greater than 1, so this should not be the side of the line that we're shading. If we wanted to pick a number up here to show that, you know, we're picking the right area, we could pick a number way up here, 1, 2, 3, 4, 5, 6. That's the point 0, 6. Again, is my y value greater than my x value? Is 6 greater than 0? Yes, it is. So this side of the line is the solution, and we should shade that side of the line. This one here is a false statement. We should not shade that side of the line. All right? So you can pick a test point, as I've done there, or you can just remember your y values are bigger. You say that. The y values are greater. All right? And remember, again, one more point, that line would be a dotted line for the less than or greater than symbol, and a solid line for the less than or equal to or greater than or equal to symbol. Now, I'm going to talk about two unique situations, a horizontal line, and then I'm going to talk about a vertical line. When you have a horizontal line, the equation for this line is, you look here, what's the point? -1, -2, -3. So basically you're saying everything bigger than -3 is part of our solution. Or in other words, on the y-axis, moving up and down, y is everything that's greater than -3. We don't care what our x values are. Every x value is part of this solution, so we don't even need to mention it. So when you're talking about horizontal lines, all right, basically it'll look like this. Now the equation of the line, if we were just looking at that line, would be y equals -3. Right? That's what this line is. Doesn't matter what the x value is, every single time y is going to be equal to 3. So that's the equation of this horizontal line. With a horizontal inequality, we're saying y is greater than -3. That means it's a dotted line first, and anything bigger than that is a solution for this equation. We don't care what the x values are. They're all part of the solution as long as y is greater than -3. Vertical lines work the same way. Notice I use a solid line with this one, so we'll be using the less than or equal to symbol. And this line, vertical line, the equation is No matter what the y value is, I don't care. The x value is always going to be equal to positive 4. So the equation for this inequality, when we highlight everything less than that value, is no matter what your y value is, we don't care. X is always less than or equal to positive 4. All right? That's everything over here on this side is shaded because that's how it's represented. So that's how we work with vertical and horizontal lines and solve equations of linear inequalities.